So right here, we've got a module called minting NFTs, and there's three learning targets. We're going to mint an asset that can't be minted again after some deadline. We're going to mint a classic Cardano NFT that complies with the SIP 25 standard. And then we're going to mint one that sort of complies with the SIP 68 standard, more kind of takes some hints about what we might be able to accomplish with some of the ideas there. Along the way, we're going to ask this question: what makes an NFT non-fungible in the first place? And so the intro is right here. You can see it on my screen. One question we might start with, because we've already been experimenting with policy ideas in this course, is does an NFT have to have a unique policy ID? Certainly, that's one way to claim that a token is unique. And there are ways to mint what's called a one-off NFT, right? That can only ever be minted once. And the way we can do that is use a Plutus script to look at the input transaction hash to a minting transaction. We're not going to look quite at that example. That's something we could look at a little bit later, especially when we get to module 205 around validator essentials. But the basic idea here is that when we talk about NFTs on Cardano, they don't often have unique, like one of one policy IDs. Often NFTs will be minted in a series as a collection. So you might have 10,000 space buds that all have the same policy ID, and each one has a different token name and different art associated with it. When we think about classic NFTs, many of them do have a locked minting policy, and we'll look at an example of that. And this just references that in a simple native script, we can put a minting deadline from which the policy ID is derived. And that way you have a guarantee that a certain policy ID can't be minted again. Then there's kind of cutting edge work when it comes to token naming. There's some really fabulous work being done using validators written in Plutus or Aiken that ensure the unique naming of individual tokens. That's a little bit beyond scope for this module, but I wanted to name that as something that we should definitely explore together sometime in the future. And that might give us material for some additional lessons. For now, we're going to start with the essentials. We're going to mint some Cardano NFTs. And like I said, along the way, we're going to wonder what makes these tokens non-fungible. We're going to encounter some really important concepts. One of them is transaction metadata. So we haven't covered this directly in the course yet, but you've seen some examples where it's quietly included in a transaction. So maybe you've noticed it. But if you haven't, this module is going to give you a chance to see how metadata works. Here's a really basic example of metadata. You have a key, which is also known as a public label for some on-chain metadata. And then you can attach some arbitrary data like a string or a number, or in this case, an entire object that consists of multiple key and value pairs. You can write plain JSON. So if you're familiar with JSON, you'll be able to write metadata. And when we get to NFTs in the second lesson, we'll see a much more complicated example of metadata that's still essentially structured like this. Now, those Cardano NFTs, they comply with what's called SIP 25, CIP, which stands for Cardano Improvement Proposal. And this was written a couple of years ago. You could see the date on it, April 8th, 2021, by Alessandro and Smog. So Smog built Pool PM. Alessandro built Lucid and Spacebuds and some other contributions across the ecosystem. We're not going to send him a mail right now. Okay. And we're going to dig into this in just a minute. But that's the other key concept we're going to cover is this concept of Cardano improvement proposals. You can review all of them at this URL right here, sips.cardano.org. And this is a really important piece of how Cardano development works, right? SIPs allow people to agree on patterns and ways of doing things so that they can better build interoperable tools. There are always new standards in development, and there's still plenty of need for new standards to emerge. So we'll look at an established one, we'll look at a newer and emerging standard, and then we're going to do something interesting by only taking bits and pieces of SIP 68, which is going to allow us to ask the question, yeah, are we really adhering to this standard right now? Or are we doing something else? And if we're doing something else, does that imply that some new standard is emerging? There's also a note up here that not all SIPs are the same. Some actually result in core functionality that's added during hard fork events on Cardano. So SIPs 31 and 32, which are linked right here, are examples of ideas that started out with the CIP process, but then ended up being integrated onto Cardano itself. And that's why these days it's already assumed that we have the ability to include reference inputs on validator spending transactions. And we have the ability to use inline datums, which in the early examples we've shown in this course is actually the only kind of datum we're using, right? So these are kind of historic documents that show where upgrades to the blockchain started. And this pattern will continue to happen, right? We're going to continue to see upgrades to the chain. SIP 1694, for example, will be implemented on mainnet at the time of is it the Chang hard fork that's coming up that brings us into the Conway era, right? So that's a pattern that we can count on to continue. Finally, at the end, we're going to look at some assignments. And we're in the process of finishing off some of the earlier assignments. But the idea here is that each one can propose important stuff that everyone should do, neat stuff that we encourage everybody to try, and tough stuff that provides an optional challenge for people wanting to go deeper. So I wanted to just highlight some of this stuff before we jump into the lessons so you can have this stuff in mind as we go through the examples. So at the end of this module, one thing you'll do is build a transaction that posts some metadata to an arbitrary key that on pre-prod hasn't actually been used yet. So it's empty. And then we're going to use the results of that in the next module in 204. And so this is a pretty simple description that obscures some of the challenges you might face along the way. Okay, but this is the challenge to everybody. After you go through lessons 203.1 through 203.3, hopefully you'll be able to build and sign and submit a transaction that puts some new metadata on chain. And you've got three choices of how to do it with Cardano CLI, with Mesh, or with Game Changer. For neat stuff, right? This is optional stuff that we really do think everybody can try. We'll invite people to combine what they learned in the first two lessons to build a time-locked NFT collection on pre-prod, where each NFT includes a different image. For people who want to go deeper, this would also be a chance to learn a little bit about IPFS, which we're not going to cover directly in these lessons, but everything you'll see when we look at minting an NFT applies to using images anywhere, whether it's IPFS or just on standard storage. And then finally, the challenge assignment here is to try to create a full implementation of SIP 68. And there's a couple of links here that people can follow through with. Now, any of these, when you get stuck on these assignments, those are great opportunities to bring questions to live coding or to the Gimbalabs Discord, or even just to other people you know who might be working through the course. And we encourage people to talk about this, to share challenges, and absolutely to share questions.